Hello, this is my English speaking practice, and I'm gonna solve this problem today, dropping rainwater. Let's go. Given n non-negative integers representing an elevation map, where the width of each ball is 1, compute how much water it can trap after raining. So the black part is the elevation map, and blue one is water, I think. So we are given height like this, and each element has one width. So 6 units of rainwater are being trapped. 1, 2, 3, 4, 5, 6. Yeah, that makes sense. Okay. Okay, I understand the problem. Let me think about the approach. Yeah, it feels like stuck problem. I think we should store the height, and if we get the greater one, for example, the one is in the stack and we get 2. In this case, yeah, the last one is the height is 1 and the position is x coordinate is 1, and at 3, when the x coordinate is 3, we have two height of Terra. Two height of bar. Okay, 2 height of bar. So we can get the 1 unit of water because the difference of x-axis is 1 and the minimum height is the the smaller height is 1, so it should be 1 by 1, 1 times 1. Yeah, the area should be 1 times 1, so we get the 1, and we store the this bar that is latest new that is the latest bar. And when we get this one, I think we should also we should store this bar as well. And when we get this one, this part should be calculated because there must be the area to trap the water. So the latest one has height 1 and the position is 1 2 3 4, and this is 6 and 1, so we can get the area that is 1 times 1. And when we get here, the latest one is here, so we have 3 widths and the smaller height is 2, but we already calculated here, so we should take it consideration. So we should be able to calculate 1 times 3 as the area to be added. So basically, when we have the taller bar, we should pop the latest bar from the stack, because the taller one should be the next left bar, right? So we can calculate the area that is fixed at the point, and push it to the stack. And when we get the smaller one, we just pop it, we just push it to the stack, because we cannot fix the area. So but I want to think about the case when we don't have this bar. So this area should be 5. In that case, the latest one is this, and when we get this is also smaller than the latest bar, so we just push it, but at the same time we should calculate this area, I think. Yeah, so the difference of x-axis is 2 and the smaller height is 1, so the area should be calculated as 2, right? And this is not I don't know, this should be added to the stack. Yeah, but this case it doesn't affect the result. When we get this one, we should calculate this part, but the latest one is here, and we already calculated this part, so yeah, we should know about that. And the latest one is this, but the difference of x-axis, x coordinate is 0, not 0, yeah, 0, yeah. Actually 1, but it is regarded as 0, and this, so in this case I think we can, yeah, we don't we should calculate the I think we should calculate the area for each bar, in the stack. So in this case we get this one, and we have 2 bars in the stack. So we calculate this, the area that is created by this and this, but there is no width, so we calculate it as 0. And when we calculate for this one, x width is 3 and height is 2. But this area should is already calculated, so yeah. So I think when we calculate this area, we should update the offset height or something like that, and that is, yeah, recorded as 1. And when we get this and calculate this one, we have offset that is 1, so it should be the height should be subtract by the offset, so the actual height would be 1 and the width is 3, so we can calculate that. And yeah, and let's assume the bar is so high and we have some bars like this. Yeah, these bars are smaller than this bar, but they for example, this bar is 4 and this bar is 3. The height is 4, 3, 2, and 1. So when we get this bar, we should calculate area for each bars. This one, and Yeah, and let's assume we already calculate this part, and when we get this, the offset should be updated to 2, height 2, and the disperse height is 3. So and we can we can calculate the area, this part, because we have height and we have offset, right? And for this part is already calculated, because when we get this one we can calculate about this. Yeah, so I think this approach would work. And yeah, it's this is a stack problem, and the time complexity we look at one by one. There is no nested loop, so should be linear algorithm. So O of n is length of height. Space complexity, we will use the stack, and it is limited by the length of height, so the space complexity is also O of n, I think. Yes, so let's call it stack is like this, and we are going to iterate through height, and the height is height at I, and what is it? Okay. And when the stack is 0 and there is a bar, we should append it to the stack, and otherwise if the height is 0, we do nothing, so continue, and we remove this condition. And yeah, if there is a height, we have some branch. They are So it would be there is two patterns. We can pop the elements from the stack, or we just add the element to the stack. The condition would be if the stack we should it might be while, because as long as the last one is smaller than the current one, we should pop it from the stack. So we use the while loop, and the last one, so last one is smaller the current one. If the last one is smaller than the current one, we can pop. Okay, I should add the index, because index is used for x coordinate. So yeah, and as long as the stack is not empty and the last element is smaller than the current one, we can pop it, right? Pop it, and the area is 0, and width would be I minus prev x minus 1, and height should be smaller one, right? Yeah, so the area is like this, but we should consider the offset. Offset is initialized here, the problem is how to decide the offset, right? I think offset would be like this, 2, 3, yeah, like this. But there is a timing when the offset should be set to 0. It's, I think, when the stack is 0, the length, when the stack is empty, it means the current bar is the highest highest bar than the bars we have met. So at that time the offset should be resetted. Because if the bar remains in the stack, it means there is a possibility, there is still possibility to calculate the area for the range, right? So we should keep the offset because we have possibility to calculate that area, so the offset will be used. Yeah. And finally we should wait. If it's smaller, we should pop it. If it's same, less than or equal to the height. We can pop it. So after this while loop, the stack might be empty, or the stack still have the bar that is higher than the current one. Hmm. Anyway, we should append it, right? Yeah, I think so. Hmm. It's a syntax error. Invalid syntax. Huh? What is... Eh? Not supported between instance nodes. Oh, yeah. This is my part. Not subscriptable, not subscriptable. Height. Height I. What's wrong? Hmm? What's wrong? Height. What? What is... Not subscriptable. Subscriptable. Oh, I see. Okay. Yeah. Looks nice. But there is error. 4, 2, 3. So it should be 2. when we get 3, 2 by 1, 2 times 1, so we added 2. Oh wait, I see. But the offsets are the different. For this, the offset is 3 at when we finish the calculating the area for between 4 and 3, but when we get 5, we have 3 and 4 in the stack, and the offset between them, the offset, oh wait, in this case the offset should be, yeah, offset should be 2, right? That makes sense. But when we calculate 5 and 2, the area is 0, but the offset should be calculated to 2, so that is good. And when we calculate this one, yeah. Oh, really? One minus 1. Zero. Oh, minus 1. Ah, I see. This is wrong. In this case, the smaller one is the current one, right? The offset should be current one. So we calculate 1, 0. 0 is wrong. Ah. Mistake. So the offset is different for each range, for the range. So the offset should be calculated, stored in the stack, or so I mean, when we append this var to the stack, this area is already calculated. So when we think about this, basically the area is calculated as like this. So when we append this bar, we should append the information about this area, right? Yeah. Thanks to this, we can calculate this area. We just subtract the area from the entire area. So the offset is not needed. When we pop Hmm. Oh. Hmm. Let me see. Really? 14. One. 6. Uh, okay. Huh? Okay. We should consider the area of bar itself. So bar itself. $12. Okay. 1 0. 1103. This is good. And 21201. Hmm? Mm. Two, 5, 0, 1, 7. But 9. 1, 2, 3, 4. 4 by 4. And I want to draw a picture, draw a figure. Let me see. Ha. Let me write 420325. 4, 2, 3, 2, 5. Okay. So so this means okay. And yeah. So when we get 3, this part is calculated and this part is calculated. The stack is 4 and 3, and this part be calculated. The problem is this. The area is 4 by 4, but we should subtract the area that is already calculated and the bar itself, right? We cannot append this one. Oh gosh. Oh, I see. So this bar are responsible for this part. So but how to handle this area? When we think about this, yeah. So how to handle this? This area, I think this area is calculated here. The A is 0 because the width is 0, so this part would be h, the height itself, height of bar itself. So yeah, when we look at this one, the 2 is added as the third element, And when we get this, let's take a look. The stack, the height is less than the current one, so we can get the previous height 2, previous x is 1, previous a is 2, right? The width is calculated, height is calculated, and the first minus is 0. No. Yeah. No. When we think about the area between this one and this one, I don't need to think about this part, because it should be just this part, this. Oh, why? What is? Oh. And when we think about this one, so let's think about the responsibility. This bar should have the responsibility about the area, the bar itself, because there is no water trapped. Okay, when we think about this, first there is a water trapped here, and it is separated. So I mean, should be correct. Should be calculated this part. When we think about this, should be so. Okay, okay. Got it. Okay. Let me think about this case. This bar should calculate three parts. Yeah, for the at first, this bar is corresponding this bar, right? This is the top of the stack. But they are they have no width, so there is no area water trapped. But this bar should have responsibility for the area of the bar itself, right? So so make it clear. So there is two concepts. It's the area of water trapped, and it's the area that should be excluded, right? And the excluded is initialized here, and every time when we pop the element from the stack, this element express the area that should be excluded, right? So for example, yeah, So when we think about this, how to fill the background. Anyway, when we think about this, one times 3 and subtract excluded area. No. It's not good. When we think about this part. So finally this part should be calculated 4 times 1, right? But I think we don't have information about this at the time, because the bar 3 is has a responsibility for this area, so we can subtract 3 by 3, which is 9. Yeah, but how to find out there is another area to be excluded? Make it simple, just have height, just have the previous height. Just have the previous height. Seems good. So offset comes back, and offset is 0 at first, and yeah. And for this, but I feel like this is already tried and it didn't work. Yes. So this would be like this. Yeah. Hmm? Oh my gosh. Why? Yeah, let's see the result and the log. 2 added 2. Zero two two 0014 022 0014. Yeah, that makes sense. Yeah, it works. And we can remove this. It's simple. Let me see. Let's go. Okay, great. Let's read down. Oh, really? There's a way to solve this problem without stuck. And this solution uses the to list. Let me see this one. This solution is 001. double pointer. We check this and this. I see. So look at this and look at this. This is calculated. This part is calculated. This part is calculated. This part is calculated. So we keep track of the highest bar for left and right, and yeah, if the left one is smaller, we increment the left pointer to the next, and if it's smaller than the current maximum left, there must be the difference, and we can make sure there is a higher bar for the right. So this area should be should trap the water, so we can add this this height difference as the area, and so on. When we get the bar like this, this part doesn't change, and when we get here, the maximum left bar is updated like this. And either bar is fine as a base bar, and we just compare and calculate the height difference. We can calculate like this. That makes sense. This is so smart. Okay. Anyway, I can solve. Okay, so it's time to finish. Thank you for watching.